Alright guys, sorry about that long video. I decided to do this. For every 10 minutes I ever go over, I'm just going to give you back a bonus point on your test. So since I'm 17 minutes over, you all got a 1.7. Yeah, now you're like, take all the time you need. Right, so I know that's brutal. I didn't mean that. I was just cruising along and the bell rang and I'm like, dadgummit. I made it a little shorter, 7th, but I'd already recorded it and uploaded it and I figured y'all were already watching. So I will really try not to do that. I just, bottom line, I spent way too much time talking about basic functions that you already knew how to graph, like the line and whatever. So I will try to do better with that. Also, in case I didn't mention it, which I think I did, I'm probably going to not focus a lot on the trig, as much on the trig stuff, because I don't feel like, because you had open notes tests, I don't feel like you probably learned the trig as well. And since we're going back through it all again anyway, I'm not really worried about whether you have mastered trig shifts and reflections in August, since we're going to go back through it and you will know it again when we go through it the second time. So anyway, so focus on, do know the basic sign. Like I may have you sketch a basic tangent curve or a basic whatever, but I'm not going to have you doing, vertical and horizontal shifts and changing the period and all that junk. They're going to be pretty basic stuff if it's on there at all. So I would not focus an overwhelming amount of time. Just the really basic stuff is all I'd really worry about on the trig stuff. All right? Anybody got any questions about anything right now? Are y'all functioning pretty well from home? I know it's not ideal, but you might like it better. I don't know. It is so easy on my part when y'all are at home because I just make one video and I don't have to suffocate, and neither do you. But right now that's what we're doing. So we're good? Okay. So we got a lot to do today. Some of it's going to be new. Some of it's going to be what you already know. Some of it can be a little bit tricky. I'll point out the stuff that tends to be missed a lot by my students in the past, but I think you're going to be okay with most of this. Okay, so the first thing I want to talk about, and this is new, it's combinations of functions. All right? Now, I don't want you to confuse combination of functions with composite functions. So I'll talk about composite functions in a second, and you'll go, oh yeah, I remember composite functions. Combinations of functions, you may not know. And this is something that I'm mentioning now because when we get to limits at the end of the year, we're going to be applying these principles as well. So here are the principles I'm talking about. If I ever give you f plus g of x, so like for instance, let's just say you had an f function and you had a g function, and I said, I want you to find f plus g of x. Well, as you might guess, f plus g of x is the same thing as that. So what I mean by that is if you had the f and the g function and I said find f of 3, you could do it two ways. You could find the f of 3 and the g of 3 and add them together, or you could add the two functions together and then plug the 3 in. But it works either way. And that's true, and I'll do an example if you want, but that's true with plus or minus. Okay? So hypothetically, if I had something like f of x equals 3x minus 1, g of x equals x cubed minus 4, and I said, what's f plus g of 2? Well, what I could do is first find, you could do one of two. So option 1 would be to take the f function, that's f of x, add it to the g function, and what I would be doing here is finding f plus g of x. So I would clean it all up, and my new function f plus g of x would be x cubed plus 3x minus 5. And at that point, if I wanted to, I could now plug the 2 in. So f plus g of 2 is what? 8 plus 6 minus 5 is 9. However, that's kind of saying find the f of g first, then plug the 2 in. The other option is just find the f of 2 and find the g of 2 and add them together. And if possible, most people would probably rather do it that way. So the f of 2 is what? 5. And the g of 2 is 4, and you add them all together and you get 9. And you can see that either way, option 1, finding the function and then doing it, same as option 2, which would be finding the individual values and then adding them together. And this property is true whether you're doing plus or minus, whether you are multiplying, and be careful, there is a difference between a dot and a little circle there. A little bitty circle there means a composite function, which I'll talk about in a second. A dot means this property. All right? So those are true, that's true, and also f divided by g of x. This is also true, with the one exception being your g of x can't be what? If it's in the denominator, it can't be 0. But I think you probably know that, because if you went to plug it in, you have 0 on the bottom, you go undefined. So it's not like that's something like, oh, don't forget that right here. You probably noticed that in Eliminate. All right? Now, make sure you realize those are combinations of functions, okay? It's not something that shows up a bunch, but when we get into limits, a lot of times you'll have something like, you know, the limit of 2x plus sine of 4x, and you don't know what a limit is yet as x approaches 0. And you may go, oh my gosh, I know what that limit is, and I know what that limit is, but I'm not sure. Well, that's a combination of a function. So it's kind of like saying that's an f plus g of x. Well, what I could do is break it up into that and take the limit of each part. And the limit of each part for you might be easier. So it's just an option you have. Like, I could redo this because of the combination of functions into 2 limits. You don't have to copy this down, but I'm just giving you an example of where this might show up. So f plus g of x is the same thing as f of x plus g of x when you approach limits or functions or all kinds of different things. All right? Okay. Composite functions. I'm going to get rid of this. We good? Okay. A composite function you already know. Although you might not know this notation. I forget. I'm pretty sure I mentioned it last year. But my brain's in a haze. So composite functions or some people call this a composition of functions. Composite functions are kind of like this. Let's just say I told you f of x was that. And let's just say I said g of x was that. Dying in here, man. Is it 71 already? It's like 75 yesterday in here. It's brutal. Y'all comfortable? I'm comfortable when I sit down. As soon as I start talking, I'm just like, ugh. All right, so composition. This part you know. Do you remember me asking you what is f of g of x? So what would you do to find f of g of x here? So technically, and nobody ever does this first part, you plug the x in the g function. Okay. What happens when you plug the x in the g function? You get g of x. So most people don't even think through that stuff. They think, I'm going to replace the g of x right here with x squared, x cubed plus 2. So, and a lot of people don't even think this step. They just jump to the end, which is fine. And then what does this tell you to do? Plug that into the f function for x. And that, when I plug it in, gives me 3 x cubed plus 2 minus 1. Now, if you skipped all of that and you just did this, I'm going to take the g, plug it into f. Take the g, plug it into f, and you just wrote this, great. That's what I do too. But I was just showing you, you could walk systematically through it. But either way, I'm at the same point, right? And then, do I stop here? No, I always want to clean it up a little bit. So my new function, f of g of x, is 3x cubed plus 5 when I distribute and add and subtract 1 from it. You with me? Now, somebody might have done this in here last year, but they always seem to do it a lot in pre-cal. At this point, people start getting a little nervous and they feel like they need to do more. And guess what they do? They set it equal to 0 and try to solve it by factoring or doing something like that. Guys, I don't want to solve for this. This is it. This is my new function. So an f of g of x is just a new function. I don't want the solutions of it or the roots of it or anything like that. Just stop. Don't go, oh, it equals 0 and try to factor or solve. Don't do that. Just stop right here. Now, your book and many college textbooks, for some reason, have gotten away from this notation. This is the way I grew up learning it. And I want to say even in college they wrote it like this. But another way of writing f of g of x is, y'all remember this? They put the f in there, and then they put this little bitty o. It almost looks like a little degree sign. And then they put the g, and they put parentheses and the x. But just remember, that and that's the same. If it bothers you, then just come over the top of it and go, okay, I don't really like that, f of g of x. But just know that f of g of x with the o means the same thing as f of g of x. Right? And remember, f of g of x is not necessarily the same thing as g of f of x. In fact, it rarely is the same thing. In fact, there's a special property if f of g of x is equal to g of f of x, then what do you know about f and g? What? Nice, nice. F and g are inverses. And do you remember essentially what inverses are? Y'all remember anything about two functions being an inverse? You do what? You switch the x and the y. Now think about that for a second. If I'm switching x's and y's, then a point like 2, 3 on one graph, if I switch the x and y becomes what? 3, 2 on the other. A point like 1, 5 becomes 5, 1. Now think about that for a second. If I'm switching x's and y's, then something like 4, 1 becomes 1, 4. Something like 5, 0 becomes 0, 5. Something like 6, negative 2 becomes negative 2, 6. And as I look at these graphs, say the graph looked like that. What are these graphs? What's their relationship? Do you remember this about inverses? They are what? Symmetric about what? They're symmetric about the y equals x. You've got y equals x symmetry. And that's true for all inverses. Are y'all seeing that? So, a couple things you're going to have to be able to do. You're going to have to be able to calculate composite functions. Not only like this, I calculated the composite function, but you also, a lot of times, don't have to find the composite function. You just have to find a value on it. So what if I had asked you, what's f of g of x, and then I asked you a little bit later, what's f of g of 1? Do you have to find the composite function and then plug a 1 in there and get 8? Or could you find g of 1 and get 3, and then take the 3 and plug it into the f and get 8? And y'all remember doing that, don't you? So know that I would not have found the function if that's all I had to do. If they ask me this, I'm plugging the 1 into the g, and then I'm getting that answer and plugging it into the f, and that's my final solution. But if they ask me for the function, in fact, you know what? I'm going to play it safe. Even if I find that function, I'm not going to plug in 1 there, Probably because of what? I could have made an error. And if I make an error, then I've missed two things, especially since there's no work here. I mean, I'm not going to miss all of this because I showed most of my work, but if I accidentally forgot to subtract 1, then it's going to snowball on me. So be careful about that. Most people don't have any issues with this. The main issue I see people having is sometimes when I say f of dot g of 3, guess what they do? They find a composite function, but it's really a, well, I erased it. It's really a multiplication combination of functions. This really wants me to do what? F of 3 times g of 3. This is not the same, I think I'm out of space, is not the same as this. Not the same. I mean, you might get lucky and they're the same. I don't know if that's lucky. It might be a coincidence that they're the same, but they are not the same in terms of the thought behind them. Are y'all seeing that? Maybe I should just say this. That function and that function are not the same. But that's one of the biggest confusions I see, that dot and that open circle. Remember, this means f of that times this g of that. This means find the g, plug it into the f. We good? Okay. Couple other things. What if I say determine I don't need the determine that if f now talk to me about this. What does this mean? Find the inverse function. Now a function, to be a function, has to do what? Pass the vertical line test to be a function. Parabolas, are they functions? Hold on. Does a parabola pass the vertical line test? So a parabola, that is a function. All right, so we're in good shape so far. I want you to find the inverse function. Now think for a second. If you know this, you wouldn't even have to work this problem. You could say there is no inverse. Because if you think about it, if that's the function, and we know, ballpark, that graphing this function would shift me down 5, right? And then it would be kind of skinny because the stretch is 3. Isn't a function and its inverse supposed to be symmetric about the y equals x? So visualize this with me. If this thing is really symmetric about y equals x, then what should the inverse, this is f, what should my inverse look like? It should look something like this, shouldn't it? You with me? That would be the inverse. There's just one problem. And what is it? Doesn't pass the vertical line test. So, could you have known that before you graphed the thing in the green or found the function in the green? I think so. Because think about it. If I'm switching x's and y's, then that means every point gets flip-flopped, but so does direction. Instead of opening up x, it's going to open up y. I'm sorry, instead of opening along the y, it's going to open along the x, or vice versa. So what that means is, if a function, like the one in the purple, doesn't pass the horizontal line test also, then the inverse won't pass the vertical. If this doesn't pass the horizontal, then the inverse doesn't pass the vertical. And if the inverse doesn't pass the vertical, it's not a function. So, we say, in order for two functions to be inverses of each other, you can write this down, in order for two functions to be inverses of each other, they must pass the what? Vertical and horizontal line test. The VLT and the HLT. So, parabolas. You know every parabola function opens up. And if you know it opens up, is there any way for it to pass the horizontal line test? No. So no parabola is ever going to have it. In fact, you might have learned, hold on. No, maybe you didn't. I think you're going to learn this very soon. In fact, it may be the next section. You're going to learn that polynomials, this is a polynomial, even though it's a small polynomial, we have a special name like parabola for it. We also have a special name if it has a 3, we call those cubics, or 4 quartics. But beyond that, we just say polynomial. Polynomials, anything that has a bunch of powers on them, and the powers are whole numbers. So for polynomials, if your highest power is even, it always goes up to the right and up to the left, or maybe down to the right and down left, but it goes in the same direction. Who knows what's going to happen in the middle? I mean, I do on a parabola, it just does that. If it was like x to the 6th, it might be like this, but in the middle it might have a bunch of wiggles. Okay? But if you know it goes in the same direction, is it ever going to pass the horizontal? No. So it's never going to have an inverse. So if I ever ask you, find the inverse, and you look at the function and it has, technically I'm talking about the first power, but it's true for any of the powers. If you ever see an even power, not going to pass the horizontal, not going to have an inverse. Now, if they're all odd, if the highest is odd right here, like a line, y equals x, x to the first, right? Or an x cubed. What's an x cubed do? Up one side, down on the other, right? X cubes have a shot of passing the horizontal. Maybe not if they have a wiggle in them. It won't, but we don't know enough now to really know that. But you've got a shot with an odd power. Not always, most of the time no, but you got a shot. On a basic x cube with no other junk on it, definitely, right? Because it just goes down all the way, or goes up all the way, or whatever. So anyway, I know that's like, ugh, it's just so much tedious junk, and what am I ever going to use this for? In calculus, there's this term called monotonistic. And they'll ask you, hey, is the function monotonistic? Monotonistic means it only increases or it only decreases. And if it's monotonistic, what two tests does it pass? Vertical and horizontal, which means it's a function and it has an inverse. And if all that's true, we have a special name for that. Anybody remember this for the gold star? If it passes the horizontal and vertical, then it is considered one-to-one. Have I ever mentioned that phrase? Probably haven't. So if all of this is true, and it passes the VLT and the HLT, we say that it is 1-to-1. And in pre-cal, that's not a huge topic of conversation, but in AP Cal, it's one of those things, these little bitty questions, here, there, that points start adding up. So they're going to mention words like monotonistic, which we'll go back over next year in calculus, which means only increasing or only decreasing, not both, which it means it can never rise and fall or fall and rise. And 1-to-1, and these points add up. And if you're worried at all about AP Cal, let me just tell you, I mean, BC calculus, they tend to move quickly. So it's not the content that's necessarily brutal, it's the pacing. And I don't even think the pacing is brutal. Most people in this class will have a similar average in BC. If they're like, if you're at, like say you have a 93 average in here, you're probably looking at a 93 average in there. Unless you get lazy, you might drop to a 83. But my A students never make worse than a B in there, but typically not. The only reason they do is they quit doing homework. Like my son, he was a low A student for me. He had a knack of just kind of barely budgeting, but he didn't do homework in BC because he was able to pick it up. He's pretty good at math. But my daughter had to do her homework all the time to be able to get her grade. But if you do the homework, you're fine. But in here, if you're in my class, which some of you don't need to be, like I have a bunch of seniors in my class that I told that should have taken BC, it's going to be a joke for them. Most people think that my AB class is easier than this pre-calc class. Because calculus isn't that hard. The thing that gets in the way of the calculus is the algebra. But you guys don't have a whole lot of holes in your algebra cheese, coming from me. Regular pre-calc people, a lot of times have a lot of holes. And that's what makes it more difficult for them. Okay? So anyway, for whatever that's worth, 1-to-1 means it passes both. And that's just something that'll probably pop up. So right here, if it said find the function, I could look at that and go, no, find the inverse. I can go, doesn't have one. Now what if it was a 3 there? Now I look at it and I go, okay, it's not even. So I know it's going in opposite directions. Plus, I know what this looks like, right? Down 5, cube. Monotonistic, it's going just increasing to the right, right? It's got a stretch on it. So I'm pretty confident it has an inverse, but here's a way you can check. What's the rules of finding an inverse again? Replace x with y and y with x. So I'm going to replace the whole y here with an x and the whole x here with a y. And if there was more than one x, I'm just going to have more than one y. And then that's technically my inverse. So this is ugly inverse. How do I make it pretty inverse? Just resolve for y. You tracking with me? So to resolve for y, I'm going to add 5. Divide both sides by 3. If you want to, you could make that 1/3 x plus 5/3. I don't care. And then cube root both sides. And do I need plus or minus on a cube root? Why not? Because a cube root of a y cubed is not absolute value, is it? But a cube root of a square root of a y squared is. And what does absolute value always end up giving you in an equation? Plus minus. And isn't the definition of a function, for each number you plug in, you get 1 y? So if I had a plus minus, that means if I plug in a number, I get 2 y's. Plus minus. Wouldn't pass the vertical line test. But because I'm only going to get 1 y here, there's no plus minus, that's a function. So to make it pretty, I replace y with f inverse of x. Copy that down. And I know if you're looking at this, you're going, hey, do I need to rationalize? And you know, in AP Cal, nobody cares if you rationalize or not at all. And you're like, sweet, why are they doing it in these grades? Good question. Maybe for standardized testing, so your answers look like my answers. Now, on a multiple choice question in AP Cal, they very well may say your answers might be rationalized, but they might not be. There's really no rhyme or reason. I make you rationalize in here, but I make an exception on that problem. Because on that problem, I really don't care. What would you have to multiply the top and the bottom by to rationalize it? Not 3. What? 9, actually. Why? Because I need 3 3's on the bottom. I only have 1. So I would have to do 9 on the top and 9 on the bottom to be able to rationalize that. So if you do it, great. If you don't, I'm not probably going to care on this. But for the rest of the year, I do have to care because they care at a math tournament. Should we go to one or have one? But that would be your inverse. Are you with me? Okay. And I want to talk about one other thing when it comes to functions, and this is new and probably the most missed thing on the test. And for you, I don't count it a lot, maybe 1 or 2 points max, because it's missed so often and you're just getting introduced to it. But you're going to see what I'm talking about in a second. All right. So, what if you had this function and this function and I'm going to ask you to find that. Now, walk with me through this. So what would you do first? You don't like the O? Okay, if you don't like the O, you're looking at that, right? So you don't change the order, you just FGX. All right? Not a lot of credit for that step, but if it makes you feel good, it's all right. Next step. Take the G, plug it in. Okay, so if I take this G function right here, square root of 9 minus x squared, and plug it in there, do I get this? Okay, great. And then can I simplify this? So when I square the square root, do I have absolute value? No, because this is not the same thing as this. Here you're squaring it on the inside. The square root of a square, absolute value. Squaring a square root just cancels them. Y'all with me? So squaring that square root cancels it and leaves me that. And what does that give me? Okay, so here's my question to you. You're good. Everybody's happy. We're rolling along here. And then I ask you this question. What is f of g of 5? And what do you get? You know, a lot of people say, if I plug a 5 in, I get negative 25. But guess what? Not good. And the question is, why not? Because this is my composite function. And the answer is, because on a composite function, what's important for you to remember, and you haven't had to remember this so far in Algebra 2, because the G function never had a domain limitation. You were always dealing with parabolas, unlimited domain, lines, unlimited domain. But now you're dealing with a what? Semicircle. Y'all remember this? 19 basic functions? Now you're dealing with a semicircle. That has a limited domain on it, doesn't it? In fact, what is the domain on that? If you were to sketch it, what would it look like? From negative 3 to 3? So this, the domain is, the domain is negative 3 to 3. So what you have to remember, this is the thing people miss. When you have a composite function, you look at the final answer. If that has a domain, great. But there's a trump card. The trump card that overrules or further limits this is not the f and the g function. It's not. It's just the g function. So if it's f of g of x, you look at the inside function, you go back and look at this, and you say, does this one have a domain issue? And if it does, you take that and you bring it down here and you say, hey, the x value has to be in between there. And that is my function. Because if I don't say that, then I think my answer is just negative x squared, which would totally give me negative 25 here, wouldn't it? But the reality of it is, if I say it now, find f of g of 5, what do? You go, wait, 5's not in the domain, D and E. But if I were to say, find f of g of 2, I could just take the 2 and plug it in and get negative 4. Now, if you're thinking to yourself, well, why don't you just not find the function and find f of g of 5 by taking the 5 and plugging it in here? Because if I did that, I'd plug it in and go, wait a minute, that's imaginary. I'm done, I'm out, no real solution. You'd be done with it, right? And I hear you, but in the process of simplifying, you lose that sometimes. And so you've got to make a mention of it if it's not understood, if it's not totally obvious. All right, so remember, the domain on a composite function is whatever the final answer suggests. Now that's a parabola, so that doesn't really have a domain issue, right? Negative to positive infinity. And then you look back at the inner function, and if the inner function also has a domain, then you have to limit what you currently had with this. Are y'all seeing that? I hope.
So if you ask us for F of G of 5, like you have to put the domain down?
If I say just f of g of 5, you can just say Denny. But if I say f of g of x, you have to put the domain down. And that's what people forget. They write that and forget this, and I'm like, and you miss a point or two. It only happened once. I'm just telling you it's going to be on there. So if you want to put a big star and say, on composite functions, don't forget that. And the sad part for you is, you've been doing composite functions since Algebra 1 probably, right? And you haven't once thought about it. And the reason why is because your inner function has always had an all reals domain, like a line or a parabola. You've never had stuff like square root functions with limited domains. You've never had stuff like semicircle functions with limited domains, logarithms. You haven't had that before until just recently at the end of last year, and that's why this is an extra thing. And it's tough for you to remember a lot of times historically because it's going against a habit you haven't ever had to have on a composite function. But that's composite functions, not combinations. Not when you're adding to or multiplying, only when you're doing a composite function. And again, don't worry about f. All we're worried about is the inner function and then any limitation, maybe the final answer gave me. And I'm compiling that together and making that my final domain. And by the way, do you know if I graph this right here, if I were to graph that function, it looks like this. Ballpark. But if I graph this, guess what it looks like? Sorry. It actually comes down here, and at -3, stops. And at +3, stops. So if I graph that one, it actually knows, oh, wait a minute, I can only go from -3 to 3. So this is great, except it's not simplified. So you want to simplify it, but go, wait, remember, that inner function had a domain issue. Y'all seen it? Okay, there's another inverse I want to mention. This is not inverses, but I'm going to jump back to inverses. I gave this on your first test, but I didn't tell you it was an inverse. You might remember it. Do you remember on your very first test last year? And I said, solve for x. And like 2/3 of you missed it, even though it was on the homework and on the review sheet, and y'all were like, y'all were new to the class, you're like, oh man, it's on the review sheet, it's number 27, he'll never touch us on that. And of course it showed up, problem number 1. And most people ended up missing it. I mean, a lot of people cross-multiplied, and then it went downhill from there. But if this is a function, and I say, find the inverse, it's kind of the same thing. Because you're still, what you're doing is the inverse, you're switching x's and y's, so that becomes an x, and that becomes a y, and now you're solving for y. Just like last year, you solved for x here. So how do you do it? Do you remember? Some of you still may have forgotten, right? Don't be the guy who misses it both years. So what would I do? I got to cross multiply, because I don't want this fraction. And by the way, this is something that we're going to be doing in AP Cal. It's not going to be an inverse. You're going to be what they call finding a differential equation. But you're going to have to get in this habit here of, okay, if I want to get my y's by themselves, and there's more than one y and I can't add them together, and why can't I add these two y's together or subtract them from each other? Because I have unlike terms, that extra x in there. But I can do this. I can move this 2y over and that 5x over, which is a start. And what can I do with that y? I can factor it out. And if I factor it out, then I can what? Divide out the 5x minus 2. And there's my y. And of course, y is the same thing as my inverse. You with me? Don't forget how to do that. That's a big deal in AP Cal from time to time. What if I said, find the inverse of this? What are you going to do? Switch the X and the Y's. You ever seen Wayne's World?
Yeah.
You remember when they did that? I don't know what time. It's a stupid movie. It's an old movie. But every time they got a sucker to do something, they'd be like, oh, you got fished in. They do gills, whatever. Why am I not going to switch X and Y? And why am I just going to say there is no inverse? Because if you have an even power in there, somewhere on there, it's not going to pass the horizontal. Like I know right now, because that's an even power, and next to the fourth graph looks a whole lot like a parabola. Sometimes it has a wiggle in there, but it means it's heading in the same direction. And if it heads in the same direction to the left and to the right, not going to pass the horizontal. And if it doesn't pass the horizontal and the vertical, it's not there's no inverse. So right here, because of that, no inverse. And then what do I have till 8:50? Okay. So the very last thing I want to ask you about is, how would you tell R, F, and G inverses of each other? Is F and G are F and G inverses of each other? Somebody give me a quick answer. Why, Claire? One's a square root, one's a parabola. That right tells me they're not going to be mirror images of each other. One looks like this, right? And the other one looks like this. That's not a mirror image, because the one like this is missing that bottom arm. And if it had the bottom arm, it wouldn't be a function anyway. And what else? That has an even power. And if that has an even power, can it even have an inverse? So this couldn't possibly be the inverse. So this would not have inverses. Let's make it work. Cube root, cube. Now let's see. How would you tell? There's lots of different ways to do this. Give me one way to tell if these two are inverses. You could graph them. If you don't have a graphing calculator, that may be a lot of work. But you could, and if you graphed them all perfectly, how would these two things look like inverses? They would be reflected across the x equals y or y equals x line. That's one way, although we all know our graphs can be a little iffy from time to time, so it might not be a great idea. Oh, by the way, if you're graphing them and checking that on your calculator, if you have a calculator and you hit whatever, window, sometimes your windows are not proportioned well. Like sometimes a tick mark on the x will be this big and a tick mark on the y will be this big. Well, that's going to make your graph look not mirrored on the y equals x. So if you do that, if you have an Inspire and you hit you hit window and then standard window on the Inspire goes -10 to 10 and like -6.7 to 6.7, and it makes it nice and proportioned. So you would see that y equals x line nice and neatly. But that's not the way I do it. Anybody else got an idea of how to check, are they inverses? Throw it out there, give me a shot. What? Somebody.
F of G of X and G of F of X.
Okay, that's perfect. I want to come back to that last. She said f of g of x is equal to g of f of x. That's the definition of an inverse function. So you could always do that, although that's a lot of work, because you have to do two composite functions, be perfectly right on them, make sure you check all the little math, and make sure that they end up exactly the same. And they should be, you should end up with x and x at the end. So that's the best way, but not necessarily the easiest way. What might be the easiest way to check if they're inverses? Couldn't you just find the inverse of one and see if it looks like the other one? And that's pretty easy, right? So I like what you said. That's the pure definition. But look, what if I just said, let me just check this definition. Change that to an x. Change that to a y. Cube both sides. Add a 2. There we go. That, same thing as that. I feel pretty good. But Jordan's method, great. If f of g of x equals g of f of x, and when you're done, you end up with x equals x, not x equals plus or minus x, not absolute value of x equals x, but if they're exactly the same, then they're inverses. So real quickly, let's check it. Plug the g in there. Right? Right? Plug the g in there. 2's cancel. What do I end up with? X, not absolute value? Why not? Because it's an odd power. All right, what about this one? Plug the f in there. What happens? So that equals that. It must be inverses of each other. No, although these don't have, yes, it would, but these don't have domain issues. But if it did have a domain issue, definitely. Like if these had been square roots, look what would have happened. When you plug it in there on a square root, you get the square root of a square. But what is that? And then over here, if you had a square root of a square, you don't get the same thing, do you? So if they had been squared in square roots, but hopefully you would have done like Claire said and said if they were squared in square roots, you know they're not inverses because this one doesn't have an inverse, that's even power. All right? Not too bad. A couple new things. Make sure you store them and look back at them because a lot of people miss a couple points just right off the top because of that. All right. Good times. Turn this off. You good?